Friends, can I get a quick confirmation? Can you see my screen and can you hear me as well? Okay. Awesome. Yes to both. Yeah, thanks, Prasanna. Yeah, that makes it simpler. Yes and yes. Yeah. Yeah, Manjunath. Yeah, thanks. Thanks all. Thanks for the confirmation. So let me just give you a brief introduction about myself. My name is Raghu, and I have 20 plus years of experience in information technology. My last 3 years primarily in big data, and I've done projects like data cleansing, and I've also migrated part of technology stack into Hadoop from Teradata and things like that. And I've also done projects to in the retailing front to find out the price elasticity of products by comparing various prices in aggregating prices, by aggregating the prices and coming up with algorithms to determine the price elasticity. And presently I'm also consulting for startups, right? So this is where I am. So friends, I'm absolutely excited to be part of this class, and I'm seeing about quite a lot of participants, so that makes it very interesting. And we have a very diverse population here, and it excites me when I have to spend the next 1 hour discussing about Hadoop and the new generation of next generation of Hadoop as well. So let's, without further ado, let's move on, friends. Just give me a minute. Yeah, here you are. Okay. So yeah, you know me now. Know your instructor. Okay. The objectives, what we are going to cover today, we will have the introduction to big data Hadoop. Yeah, definitely we will do that. And we will try to understand what is Hadoop 2 and its features. Of course, we will also, I'll also tell you what is Hadoop 1 in a nutshell. And let's understand the differences between 1 and 2, and what is yarn architecture, and and of course we'll have a Q&A if time permits. Yeah, so this is where we are. Big data and its challenges. So how many people, just a very quick gut check I want to do, how many people are familiar with Hadoop? Only I just want people to just say yes if you are familiar. The other people can remain silent here. Okay, a lot of yeses. Awesome. Okay, how many people are familiar with yarn? Yes, says Nilesh. Okay, very good. Yeah, little bit. Okay. Krishnam Raju. Okay, yarn. Okay, brilliant. Yeah, so there are people, so I mean, this is the best opportunity we have. Like, there are people where with Hadoop, and there are people with who understand yarn as well. So it's going to be interesting. So I friends, if you have any if you can add anything along the way, feel free, so that I can certainly bring it up in the class, right? So friends, before anything and everything, the big data. Okay, Krishnam says yet another resource negotiator. Yeah, that is yarn. Thanks, Krishnam. Yeah, so the big data, we all know that it is in a steep uptrend, right? So the investment for 2015 alone, it's going to be close to 40 billion, right? And we are, the industry predicts a CAGR of nearly 17% over the next 6 years. It is simply leapfrogging. It is going in a very ballistic curve. We all know this, and you can imagine the growth potential, at this rate, how it is going to go, how it is going to grow in a very steep manner, right? So, but one thing to note is, like, big data, as we speak, we are already, Hadoop was there few years back. Now people are talking about yarn and all that, and it will remain a moving target, right? Big data, just like any other technology, it'll remain a moving target. So today we'll talk yarn, tomorrow we may talk something else. You know, people are talking about Spark, Storm, and so many flavors are there. But Hadoop, the ecosystem, the basic fundamentals of Hadoop is here to stay for at least 5 years, right? Because even Hadoop is, you know, it is at a growth path. Because and Hadoop is immensely popular because, you know, it is open source, it is cost effective, and it has got various advantages. We will come to that. So big data, as you can see from this small strip, comic strip here, it says it's a collection of data sets, large, complex, difficult to process, right? It need not be just big, right? People have a perception that, you know, anything big is big data. Yeah, fundamentally yes, but it need not be the case. Anything, you know, which the traditional systems struggle to process, right, cannot scale or cannot process, right? So that is essentially your big data, right? It is very, very difficult beyond a point, right? And the traditional systems cannot scale to that extent, right? So we are talking about, you know, the megabyte, those things are extinct now. You know, we are dealing with terabytes and petabytes. You know, you have various flavors in that. You have exabyte, you have zettabyte, and you have yottabyte, if I can remember. Yeah, that's probably the highest one, I guess. So the world is growing with data, and one of the primary reasons why people are suddenly interested in big data. Can you all tell me the two essential drivers, friends? There are so many things, so many reasons. Maybe if you can just tell me the top of the mind answers why we are talking about the big data and these challenges. I think we were in this scenario even earlier as well. What do you think are the important reasons? Why is there, why is there a buzz all of a sudden? All of a sudden. No, we had the volume even earlier, but we were not really overly bothered about that. Excellent, Samajit. Samajit says cheap storage. Perfect. Customer data insights. Marcus says predictive modeling. Yeah, data is growing, need an efficient way to process. Yeah, analytics to drive revenue. Yeah, so people are realizing there is a gold mine. If the data is properly analyzed, and there is, otherwise it's as good as a dead data, right? The data is not analyzed, it's as good as, it doesn't exist. So if the data is analyzed, right? If there is data, you can analyze it, right? If it is analyzed properly, it can change the course of the, it can change the direction of a company itself, because there's a lot of insights buried underneath it, right? If only we are able to unearth that part. Digital transformation, C.G. Lee says, predictive analysis, unstructured data analytics, a lot of great points here. So the point is, like, unstructured data, that world is exploding, right? With the advent of social media coming into the mix. Social media is there, and and we have plethora of devices, like we have all this electronic devices, Fitbit, we are talking about wearables as well, right? With all this coming into the mix, it has become like, you can pull out data from varieties of sources, right? Large volume. Current solutions are not able to provide. Yeah, with large volume exploding, the traditional systems which has been time tested, which has served us for a long time, for decades, right? Like traditional RDBMS and all that, they are falling flat because they are not able to scale beyond a point, right? So it is not distributed, it is not parallel and all that, right? So here we are talking about some of the major advantages what Hadoop offers, right? It is completely cost, it provides economy on scale as well. So we will come to that part. So look at who generates big data. Of course, this is not the end of the world. We are talking about some of the big time players who have a major presence, right? Google, LinkedIn, every soul in the earth has a CV, right? And everybody needs to have a presence in LinkedIn. That has become a de facto standard for us. If somebody doesn't have a presence in LinkedIn, we start suspecting that person, this guy is not, well connected, we start scrutinizing that guy. So it has become it's more than issuing a fashion statement, right? You need to be in LinkedIn. It has become a mandatory thing, right? So even Facebook, you are connected, and Google, you need to have, YouTube. So the says, yeah. So YouTube, generates a lot of videos, and nowadays the recruiters not only look at your profile, they also look at your geo social footprint, right? They see what are all the things, if you have inappropriately mentioned, few comments in the thing, that makes them decide differently, right? So your social media presence, that's a very vital cog in the wheel today. And Hadoop, friends, can I ask you a very simple question? What is big data? What is Hadoop? Just tell me in a simple one line. Brilliant, Krishnam. Yeah, I think that's the easiest way you have explained, and excellent. Yeah, correct. Yeah. So a lot of answers coming up. So people say, yeah, big data, it is actually, more than the 3 V's, 4 V's, whatever you want to mention here. More than that, I would say, as Krishnam says, right? Big data is a problem, right? It's a problem statement. Exactly, Sudhakar, yeah? It is a problem. And Hadoop is a solution. That's all, right? And Hadoop is a framework, you can say that. It is a framework which addresses the problem in a very cost efficient, flexible, right? In a very economical way. We will see that. So sorry if before that, what is Hadoop? Yeah, so Hadoop, as you know, the definition is like, Hadoop is a framework which addresses the big data problem. Okay, so Joe is asking why I am not able to see here. No, actually, Joe, you're all muted. All of the participants are muted. Only I have the privilege of talking. So yeah, so because there are multiple participants, right? So you're all muted for now, and you will not be able to see the others' answers, I believe. So because you're a participant. So, but I'm pretty much, I'm trying to read through Joe. Not a problem. Okay, Lee is asking, Hadoop will last at least. Yeah. See, because there's a lot of investment that has gone in Lee. Yeah. Rohit, I might have missed out a few responses here and there because, if people are giving identical responses, right? So I tend to sometimes, just read the ones which are more closer. So otherwise, I generally try to look into the window, Rohit. Thanks for your understanding. Sure. So he's asking, how come? What other solution think can possibly replace it? Maybe Spark is one of the candidates for that, Lee, because Hadoop 2 yarn is very powerful, right? So, and Hadoop itself, a lot of people are jumping into Hadoop, and big data, as you know, people are still trying to dip their toe. So people have a long way to go. It's, there are technologies will be evolving, but people need to come to Hadoop, and for them to get into Spark, because Spark solves a different kind of problem, right? It performs in-memory computing and all that. So let's not digress there, but my point is, it is going to, Hadoop is there to stay for some time. Competitors to Hadoop. Yeah, I mean, SAP HANA is one of the guys, they are saying, but Hadoop is, it has got such a deep presence. So I don't think, I think they are at a driver's seat as of now. Started implementing, is it possible to get job? Sanjay, I think, yeah, we will first address the webinar. I'll take these kind of questions probably towards the end, right? Exactly. Sure, Ryan. Yeah, perfect. So friends, let's go to the questions towards the end if you're okay with that. Yeah. So Hadoop can be used for easy processing of huge data. Sure. So look at this, it's a framework. Distributed processing, large data sets across clusters of commodity computers, right? When we say simple programming model, we are referring to MapReduce and things like that. It's pretty simple, right? So it is a framework. And we are talking about, commodity computers. We are not talking about, expensive high-end servers. We are talking about low-cost, industry-specific hardware. So I want you to also, stay away from the confusion that, people think Hadoop, cheap computers, throw away desktops, laptops. No, We are not talking about those cheapo hardwares. We are talking about, fairly good terminal servers, right? We are talking about some decent servers which are low cost and industry specific, right? So those are the servers which are, generally in the range of $2,000, $3,000, right? Not much, doesn't cost you much. But when we say industry low cost, what we mean by this, and when we say commodity, what this means is actually commodity means, I'm sorry, just give me a second. Okay. Okay, sure. So commodity means, we are not trying to use some exclusive components just for Hadoop, right? For manufacturing these computers, not trying to manufacture something exclusive, right? We are just using those regular computers, using those same components, right? I mean, one other famous, even this Xbox of Microsoft, right? That uses commodity hardware. So that's pretty cheap because it uses the components which are already, produced in mass, right? So those components are actually used here, right? So used here as well. So that's why, it is costing less, and it is reliable. Reliable means Hadoop provides fault tolerance, right? Because we are talking about, data being stored and persisted in multiple nodes, right? When I say storage nodes, right, they're all commodity servers distributed along the cluster, and we have a master slave architecture here, and the slaves are going to store the physical data. And when we say reliability means it means the fault tolerance. So it is going to have redundant copies, redundant data, okay, and it stores data in blocks, right? These are some of the basic things you need to understand. So it keeps blocks in, based on the configuration what you set. If you set the replication factor is 3, by default it is 3, you can set it up, right? But generally, people, we are comfortable with 3, right? So you can set the replication factor, it is going to distribute the same block, right, across 3 nodes. Even if should the if one of the nodes go down, you can always retrieve the data from the other block, other node, right? So that's how it is. And it is very flexible. It's schema-less, can handle any kind of data, structured, unstructured, and all that flavor, right? And it is economical, as we know, because it provides, it is open source, commodity hardware, it's pretty robust and all that, and it is definitely scalable, right? So how, in the good old times of traditional computing, like if the systems were going slow, so one of the quick fix what people used to do is you add more muscle, right? Add more hardware, add more RAM, add more processing speed, right, to the single machine. But how far you can do that? You can just do to an extent. Beyond that, it's not going to fly, right? So in this one, right, we are trying to make it more scalable. If so today you're handling a cluster, which is having a size of let's say 20 terabytes, right? 20 terabytes. Now it is like tomorrow you have a need to use another 10 terabytes. So you're not panicking here. You're just going to add more nodes into the cluster. That's it. More slave nodes without much changes in the configuration. So it makes it pretty easy that way, right? So the cluster is going to handle more load, right? More volume, I would say, data volume, right? So Sandeep is asking, replication is using memory, same, so we are not wasting space. No, Sandeep, let's see, my point is like, when we say fault tolerance, reliability, right? We are talking about losing the data is a crime here, right? In any computing system, right? So here we are talking about, space. We are using commodity hardware, so we are not overly bothered that, even if it's going to take more space. So it is going to physically get stored, right? So it's not at, you think about, you're talking about wasting space, but think about losing the data. That's far more dangerous, right? So wasting the space is not a big deal here, right? So that's my point. So one other thing, friends, open source data management system with scale out architecture. Can you tell me, can you help me, what is a scale out architecture? And what is the difference between scale up and scale out, friends? Any guesses? Excellent. Yeah. Horizontal scaling, add more nodes when required, right? So that is scale out, right? So adding more servers, brilliant. So these basically horizontal scaling, yeah, perfect, friends. So it is like scale up is like, you know, adding more and more power into one machine, right? So that's we are moving away from that model, yeah. Adding more muscle, exactly, Nilesh, yeah. So yeah, thanks. Parallel and linear architecture, okay, sure. So moving on, look at the Hadoop ecosystem. So this is our ecosystem, right? Hadoop ecosystem, and you have Yarn, which does the cluster resource management, and you have this, you know, Hadoop always contains two essential components. One is the storage and one is the processing. Storage is handled by HDFS. Processing is handled by our friend Yarn here. Yeah. So when we say Yarn, we are still talking about the MapReduce, right? Which runs on top of Yarn. Yarn is a kind of platform here, right? So, and look at this. Hive and Pig Latin. Hive is used for data warehouse. It's a data warehouse system, you know, extensively used for data mining, querying, analysis, and all that. And Pig is primarily used for, you know, data transformation, right? And we also have other frameworks like MPA, message passing interface, Giraffe, it's a graphical one. So we have all these things, you know, Spark, Storm, all these flavors, right? One of the key things is like, you know, once Yarn is in the picture, all these other frameworks, they run on top of Yarn, right? Like Spark, Storm, Giraffe, and all that. But in the good old days of Hadoop 1, MapReduce was the only framework, only processing framework. So things have dramatically changed now, right? With the advent of Yarn coming into the mix. And HBase, as you know, it is a NoSQL database. It provides, you know, you can do real-time processing and all that, because people still get confused between HBase and HDFS. Both are storage, but you know, HDFS is it can swallow elephants, but it doesn't know how to, you know, if you tell, I want to see the elephant's trunk, it cannot help you, right? Because it's not very smart in processing. It can just swallow big things, right? So, but for processing something quickly, because it's generally HDFS provides high latency on queries, but HBase is pretty fast, right? So it is very fast because it can provide low latency support and all that. So that is the essential difference. And Oozie, right up there, it's a workflow tool, and you know, we all must have used or heard about workflow in different flavors, like, you know, you have Pega, you have TIBCO, you have various workflow tools that have been in the industry for a long time, like you have BizTalk and all that. But yeah, this is Oozie is the workflow for Hadoop. Yeah. So you can orchestrate the workflow, right, using Oozie. And underneath you have this Flume and Scoop, right? You have this Flume, you know, generally you can pull unstructured data. For example, you want to process Twitter feeds into the, you know, you want to move that into HDFS and, you know, process information, you can do that as well. And Scoop, you can do that as well. You can pull structured data, right? If you want to move structured information, you can use Scoop for that, right? So you can move, you can pull the data from RDBMS into HDFS, or vice versa. You can do that. So that is for structured storage. Next generation. Before that, you know, I'm just seeing one question. What is the difference between Yarn and Zookeeper? Okay. In fact, Zookeeper is one of the implementations in Yarn itself, Subhaya. Yeah. So we'll see that. Zookeeper is a, you know, I would say a distribution coordination service, right? Yeah. Alerting system. Yeah. Excellent. Yeah. It's a coordination service. Yep. That's right, Sudipta. Yeah. configuration manager. So next generation. So friends, Hadoop, before we get into next generation, we'll get into Hadoop 1.x, right? What's happening with the scheme of things. So first thing is, we have a HDFS client, right? So for, for anything and everything, right? For any, for it to access the storage, unable to see, Sanjay, you will not be able to see the chat messages because, you are chatting with me primarily. You will not see others' messages. So I am just why, I'm just doing the honor of reading the messages so that, you all get to know what is being asked, right? So client, if they want to read a file, write a file, name node is one of the essential thing because, master slave architecture in Hadoop 1.x, right? So in the sense that, any request of reading and writing, it has to go through master, right? Master is the boss here, right? So, and when I say master, it is the name node. Name node is the master daemon. So this is like, this one has the entire information about the cluster, right? Where the blocks are stored, right? In which, for example, data node is nothing but data node is a slave daemon that runs in a commodity server, right? And similarly, task tracker is a slave daemon for the processing, right? Processing is the MapReduce part, right? So anything, if you want to store the information, if you want to save some information, a file into one of the servers, you need to go through name node. Name node is going to tell, where to put the information and all that. Similarly, if the HDFS client is asking information, hey, I want this file. So it passes through the name node because name node has the cluster information. So name node gives all the details. It gives all the details about, where the blocks are located, and it may have 3 copies, right? Because we are talking about 3 as the replication factor. So but the name node determines which is the fastest way or the best optimal way to get the block. So it says to the client, hey, go and pick it up from this guy, right? This data node for this block, and go and pick up the block 2 from this data node. So it gives all the information, and the client can talk to the data node and get the blocks, right? If it is reading some file, right? And this is about the storage aspect. When you want to process some information, right? If the job is submitted and all that, so the job tracker is the boss here, right? Job tracker is the boss, and everything, the MapReduce, job tracker has the entire information. It only knows how the task trackers are located, how is it, what kind of resources are available with task tracker, which is the node which is having this task tracker running, right? Which is the one which can process information, right? Process the job, right? So when I say task tracker, right, a job could consist of multiple tasks, right? So even if you want to count the word count, which is a global example, there are so many MapReduce programs which you can write, right? So in the sense, a map is a task, reduce is a task. In between, you can have multiple mappers running in parallel. All of them become separate tasks, and you can have multiple reducers as well, right? So all these are tasks. So job tracker is the one that determines how many, where the map 1 should run, where the map task 2 should run, where the reduce task 1 should run. All that information is managed by the job tracker, because job tracker is the boss of processing aspect, right? And of course the data blocks are located in, physical blocks are located in data node. See, one of the biggest I would say limitations of Hadoop 1, right? So before we switch gears to Hadoop 2, right, you need to know the limitation of Hadoop 1. One of the limitation is like, Hadoop 1, although it has a backup mechanism, like for example, we talked about the master slave architecture, right, in Hadoop 1. So when the master comes crashing, because we know that this provides fault tolerance and all that. This crashes, we can retrieve the data from here and as well, right? All those things are there. But if the master itself crashes, right, the entire cluster keeps crashing down. Are you with me so far, friends? Are you all with me? Okay, so the entire cluster collapses if the name node collapses, right? The name node crashes, but the one of the mechanism for uh, it's I would say a disaster recovery, right? One of the mechanisms they had in Hadoop is you always configured something called a secondary name node, right? This is what, right? Secondary name node is it's a kind of backup node. So they follow something like they call it a checkpoint mechanism, right? They do a checkpointing. So where every hour, right, the information is pumped, right? They send the FS image, they call it file system image, right? That is actually sent across to the secondary name node, which updates itself, its own namespace, right? So checkpoint, yeah, correct. So it updates itself so that, for example, time is 7 a.m., let's say, right? Let's say 7 a.m. and, there is a message that is sent across the checkpointing information, right? Which is the FS image that's sent across to the secondary name node. Secondary name node updates itself so that, it is up to date. Even if this goes down, a Hadoop administrator can manually configure this to be a next active name node, right? In case this guy becomes inactive. But the problem is, secondary name node, suppose the time is like, 7:30 now, right? And the cluster goes down now, 30 minutes of information, which is the delta, right? That is lost, even if you make this as the active name node, right? Are you all getting it now? So this is the information loss or data loss, which you will experience, right? So are you getting this data loss part, friends? Yes. So is Hadoop 1 the ideal solution for mission critical application? Absolutely, right? So it is not data loss. Okay, I will explain that, Ayapperumal. Yeah, sure. So, okay, with all this fancy lingos of fault tolerance and Hadoop and all that low cost, everything, you cannot trust that because, if there is going to be a data loss, even if I lose data for a minute, I'm always perturbed, right? It is not the ideal way to go about, right? There'll be a data loss, right? So the point what I mentioned was, whatever happens, we do a checkpoint at 7 a.m., right? Then 7:10, my name node comes crashing down because whatever that has happened between 7 and 7:10, the 10 minutes of the traffic in the cluster, right? I would have done 20 reads and 15 writes and all that, right? That information, because there is an edit log that keeps logging information, right? So that information will not be up to date in the secondary name node, right? Because the next checkpointing is like 8 a.m., right? So that information, 10 minutes of data loss is data loss for me, right? You can salvage the cluster by bringing this up, right? So but whatever data that has been lost stays lost, right? So that's pretty dangerous because it is not a hot standby option. It is not an automatic failover. Okay, so it is not an automatic failover. So administrator has to manually come configure the secondary name node as the primary one. So that's how things happen, right? Starting the secondary name node. Yeah, Viru. Yeah, we are starting the secondary name node in case this becomes inaccessible or it fails. Now comes the good part. So I mean, let's look into the challenges further. So we are talking about single name node. Okay, so see, we talked about, okay, let me give you one other scenario. Generally in a cluster, multi-node cluster in Hadoop 1, what we have is we have a single name node, right? We have a single name node and we have single namespace, of course, right? And of course we will have multiple slaves. Okay, today we are handling a traffic which is like probably 20 terabytes. Tomorrow that is doubled. The day after tomorrow that is double further. So if it keeps growing at this pace, right, I have millions of files coming into my cluster. So what I will have, I'll have too many things, right? I mean, I need to have more and more nodes. So I keep adding nodes because it supports. I can do scale out, right? it supports scale-out architecture. So I keep adding more and more nodes. So beyond a point, if there are too many files, so what's going to happen? Name node is going to take a huge toll on itself, right? Because even though the cluster in the cluster, see, generally the name node is a high-end system, right? It'll run on a master server, which will be a high-end system. Whereas the commodity server, whatever we have been talking about, it is for the nodes which are storing the data, right? Name node is the one which is going to store the metadata, data about the data, right? Which is going to house the metadata. It is not going to contain the file as such, but it's going to contain the references, right? Where the blocks are located for this file, all the which rack, which server, all that information, the metadata, the location of the information and all that, right? Name node has that, right? So, but even if you have only the reference, small metadata, right? It still occupies about, 64 bytes, right? It can occupy something like that, right? Now, if you're having such information, right? Over a period of time, if you have millions and millions of files coming into the mix, it's going to be a huge, it may probably run out of RAM. It can experience a stack overflow error, right? Because you cannot burden it with too much of this thing, right? Because because it's a single name node and it can crash, right? So you have secondary name node, but that will also, that will also get into the same problem, right? So we will see, how we are solving that in Hadoop 2. Fine. So there is a question. Rohit is asking, secondary name node only activates when primary. No, secondary name node, it keeps getting the information every hour, right? The checkpointing information. But it will be configured to be the primary only if the primary name node goes down. Sudhakar is asking, what is namespace? Namespace is just like your directory, Sudhakar, just like your Windows registry, right? It has all the information. It's like a tree-like structure, right? So no high availability. When we say name node is a single point of failure, right? That means, the cluster itself keeps crashing. Need manual recovery using secondary name node, that's what. So there is no high availability, meaning if the name node crashes, some manual intervention is required and it needs to be configured. Secondary name node is brought into as a primary name node, right? So it is not a good failure mechanism, right? So it is not, and there will be a data loss, which we saw. So that's not a great option to, it doesn't provide that high availability, means, it is 24/7 available. It is not like that. And look at the job tracker. So this is from the name node side, right? Look at the job tracker front. Job tracker, similarly, we have significant amount of time and effort managing the life cycle of applications, right? So when I say life cycle, right, because job tracker, it has the entire information about, which job should be executed where and all that. But once the map task starts kicking in, for example, in a large cluster, right, we may have thousands and thousands of jobs running, right? It's not going to end in one job, right? And we are not going to sequence it like one job after. It's not going to be like, things are going to, we expect the things to happen in parallel, right? If that is the case, if one job happens, right, and the second job, that is again triggered. So if this keeps happening, right, each job could consist of multiple map tasks, multiple reduce tasks, right? So if this is the case, we are again running into a spin, right? Because job tracker may get overburdened again, because it has to ensure the life cycle of task. It has to monitor the life cycle of task. So map task, every map task has to, execute, it has to do processing, it comes to the data node, fetches the blocks and process the information, the task tracker does the processing and all that, right? So, so this is, again, job tracker is being overburdened here. So there is an elegant way in Hadoop 2. So whatever problems which you're listing it out here, there is a solution in Hadoop 2 in which they have fixed the problem. Again, map and reduce. Map reduce is, it is the processing in the Hadoop, right? Map reduce. So it has got a way, like, we do all the processing in the map and we do the aggregation in the reduce, right? So that's in a nutshell, it is map reduce, right? So humongous data stored in HDFS remains unutilized, right? Cannot be used for other workloads such as graph processing and all that, right? So we will come to that, how Hadoop 2 makes it easy, right? So there is a question like, what if the secondary name node crash? So friends, I think you can have multiple secondary name nodes configured as part of your Hadoop 1. So even if one crashes, right, you can configure. I mean, you can always question, what if the entire place is swept by tsunami, right? Or entire cluster keeps crashing? You can definitely ask that, but if such is the case, they might have put the servers, they can always put the cluster up. It spans, it is generally spans across geographies, right? So even if one place is stuck by, it's a possibility these days. We are seeing a lot of natural disasters, right? Earthquakes and all that. Even if one place is like, badly affected, you can always retrieve the information from a different location and all that. So that's how things have worked out, Pranali. Yeah. But yeah, Hadoop 2 has got a much better solution. We'll come to that. Okay. So look at some of the cool features, right? You have something called federation, right? So one name node and a single namespace, right? Here we are talking about multiple name node and namespace. So let's say, for example, friends, let's say you have you are running a business, right? And things are going great. You're maintaining a cluster. The cluster is almost pretty busy, right? You're processing, petabytes of information, and you have about 100 node cluster, right? Things are going great. Now, all of a sudden, your business has expanded, and you're acquiring another company, right? As part of acquisition, the data which the company that is being acquired, they have a cluster, they maintain a cluster which is like another, 50 terabytes, let's say. And you don't want to put this as, you want to maintain it as a separate name node, right? That's possible, federation. You can have, for example, you have a bunch of departments, right? You can have pretty much, you can have accounting department can have its own name node. And similarly, IT department can have its own name node and things like that, right? You can always make it federated. This way, you're not trying to burden your name node, right? See, are you getting what I'm saying, friends? Federation is like, you're distributing the load, right? You're making it more distributed. The load on the name node, right? Is that clear, Sudhakar? Federation. You're making it more distributed. So let me, probably talk about the high availability and come to the federation, right? So just bear with me for a few minutes. So we have high availability, and you have here it's not present. We talked about the high availability, right? Secondary name node, manual configuration, cluster keeps crashing and all that stuff, and the data is not highly available. I mean the Hadoop itself, right? So there is a manual intervention required to make the secondary name node as the primary name node and all that. So here it is highly available. So we are talking about job tracker, task tracker, what was the essential, limitation in Hadoop 1. So here we are talking about resource manager. We have something called app master, capacity scheduler, node manager. So this is your Hadoop 2 flavor of job tracker, resource manager, and you also have node manager, which is just the equivalent of task tracker. But we have app master, which is an interesting, addition here. Capacity scheduler, supports multi-tenancy and all that. But primarily, we'll talk about the app master here. Yeah. So other important salient features of Hadoop, right? So I'll explain these bullets, friends. Just bear with me in the very next slide, right? These 3 bullets. Snapshots, then network files. This is a protocol access to data in HDFS, NFS version 3, and support for running Hadoop on MS Windows. You have this, I think, Microsoft Insights, right? You have that, and you have binary compatibility for MapReduce application built on Hadoop 1. In fact, friends, if you are a Hadoop developer, I don't think you need to really worry much, because whatever Hadoop 1 will happily run in Hadoop 2, and vice versa as well, right? So from the development standpoint, is very less changes. Some of the import statements in the Java, right? You may need to make, libraries are a bit different, and few few things are little different. The tweaking is very simple. It's not very complicated. Mac OS, Shiva, I guess there is support, if I'm correct. That's a good question though. Substantial amount of integration. Primarily, Hadoop has been developed in Java and it is very comfortable in Linux and most of its distros. Binary compatibility for MapReduce built on, yeah, we talked about that. Substantial amount of integration testing with rest of the projects. Yeah. So friends, I will, yeah, okay, let's see this. Then I'll talk about high availability and all. Look at this. This is what I meant by the federation. Yeah, this is the second point is answered here. But let me talk about this, then go to the federation, right? So I just thought I'll talk about the high availability first. So friends, we spoke about, the secondary name node is not the great option, not the greatest of all the options, because, that's a way to salvage the cluster, right? Bring up the name node and all that. This can become the primary name node, but there is still a data loss and it is not a great situation to be in, right? So in the case of high availability, which is Hadoop 2, right? What we have is, we have a pretty interesting concept called standby name node, right? Standby name node is a beautiful concept. What it has is like, when I said, the FS image is a snapshot, and anything that keeps happening is that we maintain a log, which is called the shared edit logs, right? I mean, it's called edit log, which is also called the transaction log. If you do a write, if you do a read, all those things come into the log, right? So it keeps updating its namespace, right? Because things keep happening. If you're adding a file, the cluster needs to be updated, right? So it maintains in the RAM. The active name node will maintain it in the RAM. But what happens in this Hadoop 2 is like, it pumps this information into into a storage called shared edit logs, okay, which can be in one of the network drives. You can configure that. You can configure multiple copies of logs as well, right? So the active name node namespace keeps the metadata. That's right, Sudhakar. Yeah. No, it is namespace is nothing but it is just a structure. It keeps the metadata. You're right, actually. It is not different or anything. Namespace is, is just your overall, it's like your active directory, right? Sudhakar, are you getting it? Sure. Okay. So this active name node will always write instantaneously, right? Any information that is, anything that is happening in the cluster, it updates the shared edit logs, right? Which is there, it can be in a mounted drive, right? It updates, and the standby node quickly, it keeps polling that for that information, right? Anything that happens instantaneously, this name node, it kind of updates. It goes and reads this information and updates itself. It updates itself, right? Standby name node updates itself so that it is up to date with the active name node. So it is also, if this active name node crashes, right, the standby name node actually becomes the de facto active name node, right? It is configured that way, right? So it immediately becomes the active name node, and the user will not even feel that there is something happened, right? The cluster will not come down crashing and all that, right? So this provides high availability here, right? Because it is up to date, there is no data loss, and it becomes the standby name node. I mean, it can become the active if should this person go down, right? Should active go down, this becomes the next active, right? And we are also trying to explain a very important concept called fencing. Okay, fencing is what we have is like, there is always a single writer. So the standby doesn't write, the standby only reads information, right? The active name node goes and writes, the standby reads the information from the shared edit logs. Name node, actually Rohit, it is kept separately. It is kept separately. It is kept in a separate network drive. We can have multiple copies as well, but generally, people keep it separately so that, even if the you can always pull that information. It kept separately. Yeah. How? Okay. Let me, friends. What if Zookeeper uses Zookeeper to notify when the active? That's right, Praveen. Yeah. Will it uses exactly? Yeah. Zookeeper comes into play when there is a when there is a failure, right? The zookeeper, as I told you, it provides the distribution coordination, right? It notifies if there is a failure, right? Replicating the data. Actually, Saurav is asking, no, replication happens here, right? We are not talking about here. The replication, data replication, everything, the physical data is coming here, not in this place, right? So the standby has the cluster information, right? The metadata. Yeah. So the individual edit logs mutually exclusive. Yes, Samajit. So the friends, I'll come to that. My point is like, whatever active has, right, in its cluster metadata, standby has the same copy, right? Right? Instantaneous, right? So if active goes down, standby can become the active, right? So it is configured. Zookeeper, gives that, if you handle that event, right? If the master has come crashing and all that, Zookeeper can, trigger that so that, standby can become the next active. Yeah. So there is a question that, shared edit logs is also duplicated. Can be duplicated, Shivakaran. Yeah, it can be. So you also see, so this provides the high availability, and you can have multiple standbys also configured for one active name node, right? You can have multiple standbys. That is possible. Now coming back to the secondary name node, it is optional here because we don't need. Okay, Pranali is asking, how is the communication? See, there is something called heartbeats. It's also called a pulse that keeps, data node keeps sending the pulse, okay, to active name node as well as standby name node, right? It keeps sending that so that, the information, because we know that standby has to be up and running, because it has to be in the standby mode. Should there be any problem here, it quickly needs to rise up and start running, right? So it keeps sending the heartbeats to this place as well. That's how the communication happens, right? The fencing concept, fencing is like, there is only single write, meaning the active name node keeps updating the transaction log into this repository. At any given time, there is only single writer. So what if we have standby also keeps writing, right? That's going to be disastrous, right? So we want only the single writer, active name node, to keep writing, whereas the standby will listen and update itself, right? It will go and read and update itself. Shared edit log, it can be in, it can be in a separate drive, Viru, and it is not cached as such, but it will be there in the RAM of these machines, right? Yeah, Samarjit says secondary name node required to merge edit logs. No, the merge edit logs into snapshot, FS image, and sent across. That's how it happens. Yeah. So friends, let's go a little further, then I'll take few of your questions, right? So the high availability, you understand, right? Secondary name node, again, it is kept as an optional thing. We can have it or don't need to have it, but not necessary generally, since we have the standby coming into the mix, right? We don't need the secondary name node here. But tell me from your, whatever observations so far, is standby name node is going to guarantee, which definitely guarantees high availability, right? Because it is a hot standby, right? We are talking about for the active name node, right? It becomes a hot standby. But what is the limitation here, friends? Anybody can tell me this? What can be the limitation here? Okay, cluster going down. Okay, I understand all these things. Edit log crashes, yeah, excellent. Edit log crashes, you can still salvage. It can be kept in multiple places, Sri. So you can have it in different places. But yeah, my other thing what I want to share is, see, we talked about the RAM issue, right? Stack overflow, it can lead to stack overflow and all that. Yeah, but no, these things, this will, yeah, but my point is like, it can lead to stack overflow, and standby will have a similar configuration machine, right? It'll also be a similar configuration, a server which has a similar configuration. So even if name node runs out of some issue, right? It gets into some situation, standby has a similar configuration. It can also become the same, It can be the victim as well, right? So you need to reduce the burden on the name node, right? That's what we mean by the federation. So we talk about federation here, right? So here we have separate block pools here, right? Block pools in the sense, the name node 1, name node 2, you can have it like name node n, right? You can have any number of name nodes configured, and each one, it has its own autonomous namespace, right? Even if this comes crashing, these two are not affected at all. This keeps working, and you may have standby for each one of the name nodes, right? You can have standbys configured. So you are dramatically reducing the burden on the name node, right? Plus you also have this standby concept, so that makes it very powerful, right? You are distributing the load on the name node by having the having multiple name nodes, which is the federated architecture, right? And you're also making the standby configured for different name nodes, right? So that makes it pretty robust this way, right? Now you can use Hadoop, it's a lot more safer here. So it's not going to crash, if you have taken care of these aspects. And look at this. The other thing is the, okay, 1 versus 2, right? So as I told you earlier, yeah, correct. So Sandeep is asking, you can demarcate the different LOBs. Example, fantastic example, Sandeep. You're spot on. Yeah. So you can have that. So look at this. One of the significant changes is between Hadoop 1 and 2. Yarn is coming into the play here, and as I told you earlier, MapReduce was the only framework which we had it for processing in Hadoop 1, and MapReduce is one of the frameworks here, right? That's one of the biggest advantage here, and there are so many other frameworks that has come into the play. Job tracker, I'm coming to that, Sudhakar. Yeah, probably that is the next slide we have. Yeah, so Sudhakar, your thing will be answered here. This is the third bullet, right, which we saw the difference between 1 and 2. So we saw in 1, job tracker was overburdened, right? It had too many things to handle, right? It was absolutely overburdened. Now, because it had to monitor, it had to allocate the resources for all the jobs that are queuing up. That is one thing. Secondly, it had to also it gives all the information, which task tracker should do what and all that. Then it needs to monitor. Monitoring is one of the biggest tasks here, right? Because every job will have multiple tasks within it. So if it keeps monitoring, right, job tracker is like, it is absolutely overburdened. So there is a pretty interesting concept here. So, before that, I want to say resource manager is your job tracker in Hadoop 2. Node manager is your task tracker. It's just a different name here, right? So there are, a couple of interesting things. What we have done is there is an important component coming here, which is called application master, right? So application master is like a delegate, I would say, of resource manager. So what it does is like, it, as soon as a job is submitted to Hadoop, right? When it starts processing, the resource manager is smart enough to create an application master for each job. So suppose I'm having 5 jobs, friends. How many application master job resource manager should create here? Friends, 5, absolutely, right? So any number of jobs, if I have n jobs, the resource manager would have created n application masters, right? Now, what it does is like, it's just like, our day-to-day routine, right? If you are having 6 different teams we are given, right? Instead of managing, all the teams have 10 members, right? What we do, our natural instinct is to get at least one person lead the group, right? So that, we only talk to the, those leads, or, some of the leaders, and the big boss will talk to some of the important leaders. He will not talk to each and every individual. Then he will burn out, right? That was the scene of Hadoop 1. Here, Hadoop 2, it is like, it is smart enough to delegate that, the task monitoring activity, to application master, right? So what it does is like, it brings in application master, it creates and says, hey, better go and, these are all the tasks you need to be running for this job, right? It tells the application master, okay, here is the list of, you have 5 map tasks and 2 reduced tasks, go ahead and run this and go ahead and run it in these machines, right? These machines, it will say. Machines is like the node manager, right? Which keeps the heavy lifting of all the tasks and all that. So it will go and tell it. An application master will go and negotiate. Where does application run? It runs in the commodity server, Samarjit. It will be running in the node manager, to be precise, right? So it will go and ensure the tasks are run properly. Tasks are, run properly in all these node managers, right? So this is where application master, and finally it hands over the status. It finally says, okay, all these things are done. And who does it communicate to? It communicates to the resource manager. Okay, it communicates to the resource manager and it unregisters itself, right? It has got a short life here, right? Whereas resource manager has the cluster level resource manager. It has got a high long life. It is generally, it is this daemon runs along with the name node, right? So name node and AM, no, two different things, right, Sudhakar? We are not talking about the application master is different. It comes in the processing front. Name node is something in the storage, right? Node manager, okay, sorry. Node manager, okay, sorry about that. Okay, node manager is the one which actually does the it actually does the processing of the task, right? Application master is the one which oversees the processing, right? It is like, friends, just for your, it is like a manager is a resource manager, put it this way, right? And a developer is a node manager, right? And you are getting a consultant or a lead consultant, right, who will oversee the work of a particular project, right? So you will delegate that. So this delegate will work with all the developers assigned to him or her and ensure the job is completed. Once the project is delivered, he'll go and update the boss, which is the resource manager. So this is how you should understand. Is that clear, friends? Yeah? Is that clear? Okay. So thanks. Yeah, I mean, this is all you need to understand. Now I'll talk about the container. Container is nothing but, it's just a, a place where you allocate some resources, right? So that, the tasks run successfully. Even for resource manager to create an application master, because application master is actually created within one of the node managers, right? So it runs within a particular block, which is called the container, right? Which is nothing. The container will have the CPU, CPU time, and it'll also have the memory for it, all those things, right? It is blocked within a particular node where the map task or the reduce task or the application master is supposed to run. So all that information, he decides it. This resource manager is the big boss, right? He decides, okay, here is where the application master should run. And he also tells the app master, go and figure out, okay, these are all the tasks to be run. 5 map tasks, 1 reducer. Go and run it in this node, this node. He may say node manager 1, node manager 2 and all that, right? For all you know, it can run in the node where the app master is also running, right? So all these tasks will run within a container. Container is nothing but a space allocated for these tasks to run. That's all. Is that clear, friends? So after the job is done, generally, just to sound very brutally, right? What we do, we hire a consultant for a particular task, particular job to be project to be delivered. Once the project is delivered, we don't need the consultant. We generally kick that person out. Okay, your job is done, well done. Yeah. Similarly, the app master, it does all these things, goes back and communicates, rather it handshakes with the resource manager. Yes, you gave me the monitoring aspect. I monitored all the tasks are completed. It unregisters itself. The job is done, right? So another job is completed, initiated. Resource manager is going to create another app master. Clear, friends? I think we are 5 minutes away from the clock. I mean, outside. So let me, I think we covered the 3 main aspects of Hadoop 2, and look at the uptrend of Hadoop 2, right? I'm sorry. Just give me a minute. The question window keeps vanishing sometimes. Yeah, sorry. Just give me a minute. One map task, one app. No, Sudhakar, it's not map task. One job. One job can have multiple thousands of map tasks, right? So one job, one app master. So that is your. So app master will monitor all the map task and the reduced task of a particular job. Is that correct, Sudhakar? You getting it right? Yeah. So job trend looks pretty impressive, and I think the world is with us, friends. We just need to get in here. Hierarchy, resource manager, app master, node manager. Perfect, Sudipta. Perfect. That's the correct one. Can we get this presentation? I think they generally share it, Sri. I'm not sure. Maybe you may need to drop in a drop a mail. I think I guess they should be sharing, possibly. So, friends, any other questions which you want me to answer before we wrap up? Hope you enjoyed. I think maybe I can take like 4 or 5 questions if I get the PPT format to save. Okay, sure. You may probably ask this question, friends. So maybe you may get it for all you know. Again, I lost the question window. Sorry. Okay. 2+ overall experience, market acceptable. Yeah, absolutely. There is no. When is the next webinar? I think Skillspeed should be able to handle this. I think there are a lot of webinars planned, Sri. This is not end of the world. So I think Skillspeed has got, they are really onto this, and they've got amazing content as well. So I think they have planned series of webinars, and you can check with them. 2+ market acceptable. So I think market is pretty good, very vibrant, friends. And big data, as I told you, it is just growing. It's booming, right? And you will see the boom in the years to come, right? So there is no limit here. So please get in, and you need to, it is like, in the next 5 years, right? Because the data is growing, analytics is growing, a lot of things are growing, right? So it's a very fascinating aspect, fascinating field, and people are getting in, right? So companies are, suddenly getting in and all that. So great time for the data folks. Java expertise mandatory for learning. Yeah, I mean, I would say it's one of the preferred one, but it's not end of the world if you don't know Java. There are a lot of other alternatives. So if you don't know Java, don't crib about it. App master and overhead. No, it is not an overhead, right, Sandeep? It kind of app master, what you saw, it is actually reducing the burden on the job tracker, if you see that, right? Without any project work, Sanjay is asking, possible to get job? Yeah, in fact, Sanjay, I would say, do a project. If you can take up a course, wonderful. But I'm not campaigning for that. But yeah, if you know good Hadoop with some hands-on, right? Good. So that but or at least you should have done a project, because most of them, they want you to be a little hands-on with whatever you're talking, right? That will be great. Rohit is asking map task, reduce task. No, I thought Rohit, map task is the one where we do processing, Rohit, and reduce is to aggregate the information, right? Reduce is, we put processing all the map tasks together, right? Then we produce the result in a nutshell, Rohit. Huge number of app manager to handle. At a point, won't it be, Saurav is asking, app manager to handle. So it is not like that, Saurav. It's like one job, one app manager. But you are right. But app manager for a job is just one. But one job could consist of thousands of map tasks, right? So instead of monitoring 1,000 map tasks, right? Thousands and thousands, job tracker is only going to monitor one app manager. Is that clear, Saurav? Mainframe to Hadoop, Siva. Good luck for that. Do we have webinars for MapReduce? You may need to check with the Skillspeed. What about beginners? Hands-on expertise. Okay, 1 year experience. I think, friends, these kind of questions, right? I would say, my general answer to this is like, if you are good in Hadoop ecosystem, right? Overall, right? See, there are various flavors within Hadoop itself. You can become an architect, you can become a HBase architect, you can become a MapReduce programmer, you can become a Hadoop developer, you can become a HDFS administrator. So many flavors are there. So it is, the world is vast, and you cannot target everything. So, but you can focus on, maybe you can look at the ecosystem and see what best thing fits your kind of profile, and take it up, right? Project experience. Sanjay, I missed Sanjay with okay. Live project experience. No, Sanjay, that is not needed, because a lot of people, companies understand that as well. Because when you get in here, right, you may not have the live project experience, but if you can still showcase. Some people take up certification, but I would say project experience is more vital. That's where you develop the hands-on, right? If you do one or two big, a good case study, right, a good use case, that'll be good. Cloudera, Hortonworks, Mapper, yeah, correct. Yeah, you can take any of these flavors, Sandeep. So system tracks, track a person. System which tracks CC cams of state to track a person. Yeah, all these are great examples. Hadoop admin course guidance. I am okay. There is a good plan to change to admin. Sure, Rohit. In fact, Hadoop admin is a vast field by itself, right? You can see how you can port the data into Hadoop if needed, and you can go from there. Freshers, yeah, there are folks who are trained by freshers as well. So friends, .NET to Hadoop, yeah, great. One active, how many data nodes are required? Certification necessary. I think a lot of, maybe I'll take a couple of them from here, and then we can wrap up, friends, right? I work for, a telecom startup. So what is the future when we convert mainframe to big data? I think a lot of systems would, coexist, friends. So that's the way the world is headed, right? In many companies, we still have mainframe, we have Unix-based ones, and you have Java applications, you have .NET. These things are bound to remain this way. So, but people are generally migrating to, because we are getting big data scenarios, right? We are facing them. So people are, migrating to, Hadoop systems. A lot of people are talking about migration, so it's a great thing to have. Moving from mainframe to Hadoop. So friends, if you have the overall aptitude for computing, right, the distributed computing and all that, even IBM had its distributed computing back in mainframe days. So if you have that aptitude, you can very well move in that front. Yeah, that's fine. So certification necessary, I don't think it is really necessary. That's one of the aspects, but I would say projects are more important. Yeah. So friends, I think with this I'll wrap up the session. So hope you all had something to learn today. So I felt it personally. I felt very privileged to have spent the time with you, because a lot of great questions, and I might have missed out or overlooked, friends, some of the questions. Sorry about that, because the window keeps flying, right, as the questions keep pouring in. So I hope I was able to answer most of your questions. If not, you can always you can loop back with Skillspeed and try to find out what is the best way out. So you all have a great day and a great evening, and thanks. I look forward to catch up with you sometime in the future, right? So thanks, friends. Thank you so much. And friends, one other thing, please, if there is a feedback coming up, please express yourself, right? That'll be great if you can express your feedback and thoughts, suggestions, and all that. Thank you so much.